Hi, we are testRigor and welcome to our channel. testRigor is an intelligent, generative, AI-powered codeless test automation tool that lets you write test cases in plain English. Like and subscribe to this channel to stay updated with more helpful videos. Looking to level up your testing game? This video is your go-to guide for all things Selenium with Java, plus a peek at testRigor, the AI tool that automates without writing code. Let's jump in. Selenium is a popular test automation tool that supports different programming languages to write test scripts. Of all the possible languages, though, Java is the most widely used one. While there's a lot you can do with Selenium, here's a cheat sheet that will help you write effective test automation scripts using Java. Whether you're a beginner or a pro, you can use this quick guide to refresh your memory. Let's get started. Driver initialization. Once you've prepped your system with all the software needed to support Selenium and Java, you need to initialize drivers. This is always one of the first steps of writing Selenium test scripts. Initializing drivers means that you are telling Selenium which browser you want to test your application on. Once Selenium executes this statement, it will open an instance of that browser for you and run your web application over there. An object of this WebDriver class is needed to interact with any element seen on the screen. The screen shows the Java commands for driver initialization for Chrome, Firefox, Edge, and Safari. Locating elements. Writing test scripts with Selenium primarily focuses on verifying interactions between elements seen on the screen. You might want to check what happens when you click a button or need to fill in text into fields seen on the screen. Each UI element has its own place in the page structure, and you need to use those details to uniquely identify them. Selenium offers various built-in functions to interact with different types of UI elements. These functions use various aspects of these elements like ID, class name, tag name, CSS selector, XPath, or link text to pinpoint the desired element. Thus, we can say that to access a UI element, one needs to drill down. You start with the driver object to interact with that browser instance, then decide the built-in function you want to use. Like find element in this case, choose the mode of identifying that element, and finally give the actual value like the tag name or ID. The table shows examples of how you can use these different aspects, or attributes, of UI elements to interact with them. TestNG. You can use TestNG to create well-structured, efficient, and maintainable Selenium test suites. This framework provides you with a set of annotations and configurations that tell Selenium when to run a particular script. Should it be run before or after the entire test suite is executed? If a script is a test case, and whether a script should run before or after every test case in the suite? Here's a quick summation of the TestNG annotations you might use frequently. JUnit. JUnit is a popular test automation framework that is also used with Selenium at times. Though it's primarily used for unit testing, you can use JUnit for its test runner to execute tests, its assertion methods, and its annotations to organize test scripts. This table shows JUnit annotations. Similar to TestNG annotations, JUnit also offers annotations that help classify test scripts in different ways to determine when Selenium should run those scripts. Working with files. If you want to upload a file as a part of a test case, Selenium lets you do it. Selenium will require you to first find the exact UI element through which you can upload the file, provide the file, and then click on the Submit button. If you look at the two commands on the screen, you'll see this being done. We are using driver find element to locate the UI element, which will let us upload the file. But since we are not done with this UI element just yet, we use the send keys function to send the file path to that UI element. Finally, we look for the submit button and perform the file submission operation. Let's say you want to read characters from a file, either for a test case or for data-driven testing. Selenium offers a couple of ways to do it. Java's input-output package comprises of a couple of classes that can be helpful. The first way to do it is using the BufferedReader class. It buffers characters, which means it reads characters in larger chunks and stores them in a buffer. This significantly improves the performance of reading operations, especially when dealing with large files. To use this class, you need an object from the FileReader class. If you look at the code snippet, we are first creating an object of the FileReader class that has access to the text file we want to operate with. This FileReader object is then passed to the BufferedReader object because BufferedReader needs FileReader for this operation. Once this initialization is done, a variable of string type holds the characters that are read from the text file. Finally, a loop is used to read the lines from the file and print them on the screen. Once the file has been read, close the stream. In fact, this needs to be a mandatory step for every file reading operation. The second way is to use InputStream, an abstract class, which represents an input stream of bytes. It serves as the base class for various input streams, including file input streams, network input streams, and more. In this example, we are using file input stream, which is a subclass of input stream to read bytes from the file. These bytes are being converted into a specific format using the InputStream reader. This operation is happening 1 byte at a time, and hence we have a variable of character type which is being used in the loop to print every character on the screen. The next method is to use the FileReader, which is a fundamental class for reading character-based files. You need to create an object of the FileReader class that has access to the text file we want to work with. Then create a loop and print character by character on the screen. You can read data from CSV files as well. Here's an example of how to read data from a CSV file using the OpenCSV library and process it in Java. This code is useful for extracting data from CSV files, which can then be used for various purposes like providing input data for Selenium tests. In this example, we create a reader object to read the file and a CSV reader object to read CSV files specifically. Once the objects are initialized, we read all the data from the CSV file and store it in a list. Finally, we loop through the data and print each value from the CSV file. Selenium can also work with Excel files. This code reaches into a specific location on your computer, opens a particular Excel file, goes to the student data sheet, picks the value from the 2nd row and 6th column, and then prints that value. To do this, you need to import the necessary libraries and define the path of the file in your computer. Using File InputStream, open the Excel file and then load it into a workbook object. Now select the sheet, row, and column you want to read and print its content. Selenium Navigators. You can perform browser-level actions like refresh the page, go forward or backward in history, and navigate to a specific URL in Selenium. Working with Windows. Selenium lets you work with browser windows by allowing you to toggle between them. Close or open windows, adjust the size of windows, and even take a screenshot of the window. Working with frames. Web pages can have frames that help divide the page into independent sections for displaying content. With Selenium, you can interact with these frames as well. You can toggle between frames and the main content using the displayed commands. Working with alerts. Alerts are quite common in web pages and need to be dealt with during test automation. Selenium offers ways to interact with these alerts too, as shown on this screen. Apart from the previously mentioned categories, here are some of the common operations that you'll find yourself needing when writing Selenium scripts. Number 1, launch a web page. You can launch a web page using the driver object. Number 2, click a button. To click on a button, which is one of the most common UI interactions you'll automate, you need to find the button and then click on it. For this, use the web element class, which represents an individual HTML element on a web page. Think of it as a digital representation of an element like a button, text box, link, or any other interactive component. Number 3, accept an alert pop-up. Using the driver object, you can close, reject, or accept alert pop-ups. Number 4, print the page title. Selenium has a function that fetches the page title for you. You can then print it or use it however you wish. Number 5, implicit wait. You can make the test execution pause for a while using Selenium waits. An implicit wait sets a default time for the web driver to wait for elements to be available before throwing a no such element exception. Hence, it is applied to the driver object. Number 6, explicit wait. An explicit wait sets a specific wait for a particular element to be available or a specific condition to be met. Number 7, sleep. The sleep operation lets you pause the execution of the script for a specified amount of time. Number 8, clear the input field. At times, you may need to clear an input field. For that, you can use the clear function of the web element class. Number 9, disable a field. If you want to directly manipulate DOM elements without using Selenium's built-in methods, then the JavaScript executor, which is an interface in Selenium WebDriver, needs to be used. You can disable elements and then enable them again using JavaScript. Number 10, enable a field. Selenium Grid. With Selenium Grid, you can handle parallel test execution with ease. To use Selenium Grid, you need to download the latest Selenium server jar file, set up the hub, and start the node. Here are the commands for it. Alternative: write tests without a single line of code. In the age of AI and fast-paced development, you will need something more than what Selenium has to offer. By leveraging plain English statements and an advanced AI engine, testRigor provides excellent scalability, minimal maintenance, and faster test execution, setting itself apart from coded automation tools such as Selenium. Here's an example of a Selenium test case for logging in. For a simple operation like this, you need to go through the hassle of writing lines of code, working with brittle UI element identifiers, and still not know if the test will run properly. On the contrary, if the same test case were to be run in testRigor, here's how it would look. That's it, just 2 lines, and with stable test runs and bare minimum test maintenance. Organizations that have adopted testRigor have experienced significant improvements in their software testing processes. With increased test coverage, reduced defect escape rates, and accelerated release cycles. The platform not only enhances QA teams and delivery processes, but also eliminates the need for maintaining testing infrastructure. The unique approach of testRigor allows for seamless collaboration among team members and ensures tests remain valid even after underlying framework changes or refactoring. This superior choice in test automation provides numerous key benefits, including cost savings, improved communication, and detailed test results for seamless debugging. We're done with the video. If you like the content, please leave a like and subscribe to our channel for more informative content on artificial intelligence, software testing, and engineering. Your support helps us build more content to help you further. If you have any questions, please let us know in the comment section. We will try to provide the best possible answer and learn with you together. Ready to see how we can help streamline your testing process? Book a demo today with our specialists to get a personalized walkthrough of testRigor.